Hello, children, and welcome to the class today. We are going to learn about some natural phenomena in this class. You understand what is a natural phenomena? So let's take an example. For example, you burst a cracker. There is a lot of noise. There is a lot of smoke that is coming out. This phenomena is not a natural phenomena. It is not occurring on its own. You are doing it. On the other hand, when there is very, very heavy rain, there are thunderstorms, when you can see lightning across the sky, that is not created by you. That is a natural phenomena. And we are going to learn about some natural phenomena in this chapter. We are also going to learn that these natural phenomena can be very dangerous. There are certain tips that we need to keep in mind when such natural phenomena occur in our environment. Now, to begin with, let us talk about electric charges. If a body is rubbed together with another body, it produces heat. If you've ever experienced how rubbing your palms together feel. In the same way, when you brush your hair, sometimes you feel that the brush is sticking to your hair. What is happening here? Let us understand. So, when two bodies are rubbed together, they are said to have acquired an electric charge because the body is charged. That is why it is attracting your hair. Now, in such a body, electric charges are at rest. This electricity inside the comb that is developed because of your rubbing it on your hair is known as static electricity. Now, all the charged bodies have the ability to attract pieces of paper, wood, feather, etc. Now, does it mean that all these objects that we are talking about have acquired a charge? Yes, it has. We will understand in more detail what electric charge is. Let us watch a short video. You must have witnessed lightning in the sky. These are electric sparks that occur when electrical charges flow from one cloud to another or within the same cloud. Let us first learn about electrical charges. When two objects are rubbed together against each other, both get charged. They acquire equal and opposite charge. The object that gains electrons becomes negatively charged, and those that lose electrons become positively charged. Charging occurs by rubbing. Now let us take the example of a comb. When you rub the comb over your hair and then bring it near tiny pieces of paper, they are attracted towards the comb. Similarly, if you bring a balloon close to a woolen sweater and rub it on the woolen sweater, the balloon is charged. And as you can see, the balloon gets attracted to the wall without any external force. The comb, the balloon, all these are said to be electrically charged. So children, we need to remember that every body has got a positive and a negative charge. Now, in every object, there is a balance between the positive and the negative charges. Suppose a body loses negative charge, it will become positively charged. And if a body loses positive charge, it is going to become negatively charged. Now, for experimental purposes, it is believed that a glass rod, when rubbed over silk, gains a positive charge, and an ebonite rod rubbed over flannel or fur gains a negative charge. So, if the glass rod is brought closer to the ebonite rod, they are going to attract each other, as in this case, because the charges are opposite. Opposite charges attract each other. On the other hand, if you bring a charged glass rod closer to a charged glass rod, both of them will have a positive charge. What will happen in this case? In this case, both the glass rods will repel each other. So we understand that like charges repel each other and unlike charges attract each other. Let us now understand the different ways by which we can charge a body. So the first way in which we charge a body is by friction or by rubbing, which we have already seen in the video we just viewed. The second method is charging by contact or conduction. As you can see in this experiment given in your book, an aluminum foil piece was rolled over a pencil and made a cylinder. Now we have gently pulled out the pencil and we have suspended the aluminum cylinder with a thread. Now touch the cylinder with a glass rod. अभी अभी हमने पढ़ा था कि ग्लास रॉड को एक्सपेरिमेंटल बेसिस के लिए we believe that it is positively charged. जब हम ग्लास रॉड को एल्यूमिनियम सिलेंडर के पास लाते हैं वो रिपेल हो जाता है और जब हम एबोनाइट रॉड को एल्यूमिनियम सिलेंडर के पास लाते हैं वो अट्रैक्ट हो जाता है. अब यहाँ हो क्या रहा है? We observe that the aluminum cylinder is repelled by the charged glass rod. On the other hand, it is attracted by the charged ebonite rod. This means that while we were rolling the aluminum foil, there was some charge that developed into it. Now, bodies can be charged by contact. So, by the method of conduction. This is the same thing that happened with the aluminum foil when we brought the glass rod and the ebonite rod closer to it, in contact with it, the aluminum cylinder also started behaving like a charged body. The second way of transferring charges to a body is by induction. Induction के अंदर क्या होता है? Induction के अंदर positively charged rod को एक end of an uncharged rod के पास ले आते हैं, but we do not touch the two rods together. इतना पास लाने से भी till the two rods are close to each other, they behave like charged objects. The minute you will take the charged rod away from the body, it will again start behaving like an uncharged neutral body. Now let us understand how this experiment of glass rod containing a positive charge, ebonite containing a negative charge, and the understanding that charges move from body to body were discovered by watching a short video. The transfer of charges can be understood with the help of a gold leaf electroscope. A gold leaf electroscope consists of a brass rod which passes through a rubber stopper into a glass jar. The top part of the brass rod has a brass disc and the lower end, that is inside the glass jar, has two thin leaves. Charge a glass rod by rubbing it with a silk cloth. We know that it becomes positively charged. Take a gold leaf electroscope in which the leaves are folded. Bring the charged glass rod in contact with the brass disc of the electroscope. You will observe that the gold leaves diverge. The positive charge gets transferred to the gold leaves through the brass rod. The gold leaves diverge. The positive charge gets transferred to the gold leaves through the brass rod. The gold leaves diverge because they carry similar charge. You have learned that like charges repel. So from this you can conclude that electric charge can be transferred from a charged body to another through a metal conductor. Now remove the glass rod and touch the brass disc with your hand. The gold leaves collapse and come back to their original position. This happens because the gold leaves of electroscope lose charge to the earth through your body. The process of transferring a charge from a charged body to the earth is called earthing. So children, from this experiment you understood how we can find out whether a body is charged or it is not charged, and we have also learned about earthing. Now we have to remember that there are certain elements like all the metals, copper, etc., which are good conductor of electricity. On the other hand, non-metals are insulators. They do not conduct electricity. They do not allow charges to pass through them. also wood, plastic, etc. are also poor conductors of electricity. That is why you must have seen copper wires have a plastic coating on their top. This is so that the electric current does not affect the person holding the wire. Now, based on the concept of electrical charges, let us understand about a natural phenomena called lightning. Lightning, as we all see, accompanies a very heavy rainfall, which is also included with thunderstorms. Now, let us understand more about lightning through these videos. During a thunderstorm, the air current moves upwards and the water droplets move downwards. A cloud has negative charges concentrated at the base and positive charges concentrated at the upper region. When a charged cloud passes over a tall building, a tree, or the ground, the negative charges from the base of the cloud pulls the positive charges from the tall building, trees, or the ground at a very high speed. When the positive and negative charges connect, it gives rise to an electric discharge in the form of lightning. The lightning conductor is installed on all top buildings to protect the building from the effect of lightning. It is a long rod of copper or iron that runs from the top to the bottom of the building. The lower end of the rod has a metallic plate made of copper, which is buried deep into the earth. When lightning strikes, the conductor provides a path for the charge to pass through the earth, thus protecting the building from being damaged. When lightning and thunder occur, move to a safe place like inside the house or in a car with its windows and doors shut. Do not take shelter under tall trees or buildings or elevated places. You may, however, take shelter under short trees as they are small and less likely to be struck by lightning. Crouch on your knees with your head between your arms. This makes you the smallest object that is less likely to be struck by lightning. Stay away from water bodies as water is a very good conductor of electricity, and for the same reason, if you are inside the house, do not bathe when there is lightning outside. Do not put in electric devices. Use a mobile phone in place of a landline as lightning is more likely to strike a telephone pole. So children, you have learned so much about lightning in these videos. Now it is important to understand that lightning and thunder are produced at the same time. However, you see the lightning first and hear the thunder later. Why is it so? Because light travels at a faster speed than sound. So you get to see first and you hear later on. Now this was about the phenomena of lightning, and we have also discussed the precautions that we should take when there is lightning outside. Now let us discuss about another natural phenomena which causes dangerous repercussions for life, property, and also natural resources. This natural phenomena is known as earthquake. We all know कि जब earthquake आता है तो earth बहुत जोर का shake होना शुरू हो जाती है. Now, the earthquake is actually the shaking of the ground, and it also causes trembling at places. This is because the earth is made up of three layers: the crust, the mantle, and the core. Crust is the outer layer, mantle is the inner layer, and core is the innermost layer of this earth. Now, the entire earth is formed by layers. There are about 7 tectonic plates or areas where the plates of the earth meet all across the world. These plates under the surface of the earth keep rubbing against each other, and sometimes this rubbing may become very, very hard. At that time, earthquake or tremors are felt on the earth. These can cause damage to both life and property, as I just mentioned. Now, having known what an earthquake is, how do you know how to measure the earthquake? And what is the area that is going to be affected most by the earthquake? Let us learn that. Now, focus is a point from where the earthquake waves arise and they travel all the way up to the epicenter. The epicenter will be the area which will have maximum destruction during the time of an earthquake. Now, before the earthquake, there are means and ways of measuring the intensity of the earthquake. Now, the point from where the earthquake arises, a seismograph tells us what is the strength of the earthquake. It tells us about the intensity and the damage the earthquake can bring to people inhabiting the earth. So, earthquake with a magnitude of about 2 is very mild, about 3 to 3.5 is moderate, 5.6 to 7 are strong, and 7.1 to 7.9 are very strong. These earthquakes can damage life and property. In fact, there are earthquakes that go beyond 8 also. These earthquakes have the capacity of destroying an entire city, town, or even a country because they are so powerful. In fact, earthquakes also occur inside the ocean. And because of these earthquakes inside the ocean, the trembling of the earth is what causes rise of tsunamis, which is generally experienced in the coastal areas. Now, what happens when an earthquake strikes? How do you save yourself during the time of earthquake? The first way is to make earthquake-proof buildings. Nowadays, there are such intensive techniques that the foundation of the houses is made in such a way that the entire building becomes earthquake-proof. The important things to do when there is an earthquake is you should take cover immediately under a study desk so that if the ceiling falls, it does not fall directly on your head. If there is no table or desk, you should hide against an inside wall, away from windows, bookcases, or furniture that could fall on you. Do not go to another room. Even after the shaking stops, there may be after tremors also. Stay in the place that you are in. You should shut off kitchen gas. Keep water, foodstuff, and first aid material always ready in case you are staying in an earthquake prone zone. Heavy objects or glasses should be kept on the lower shelves. You should not immediately light candles or switch on electric mains right after the earthquake. If you're outside when a quake begins, move away from buildings and trees. Drop to the ground. If you are in a car, slow down and drive to a place that is away from the power lines and expect aftershock after the earthquake stops. So children, in this lesson, we have learned about two natural phenomena like lightning and earthquakes. We have also learned how earthquakes are capable of causing huge tsunamis in sea around the coastal areas. So it is very, very important for us to hear warnings when they are announced by the meteorological department. Follow these precautions very carefully and stay safe. Thank you.